Okay, so 6-4 is all about completing the square. And I know you completed the square in Algebra 1, but completing the square is just another method for us to solve quadratics. Okay? When we were graphing them and looking at the graph, and we would see that they didn't cross at a nice pretty number. So, for example, like number 2 on your worksheet there, he didn't cross at a nice pretty number of 3 or 5. He crossed in between 3 and 4, and then he crossed between 4 and 5. So I got these decimal approximation here, but those aren't exact values. Okay? So if I want to say this is exactly where he crosses the x-axis, or I want the exact solution, then I probably need some other method to do that. Okay? Sometimes we end up with answers that have radicals in them. Like on your test, you ended up with like the square root of 3 or something like that, or the square root of 6 root 5 or something like that. That's its exact form. We could put it in our calculator and get a decimal approximation, but I want to know where his exact solution is. So when I graph him, I can't see those exact solutions. When I factor him, if he's got a radical in him, he won't exactly factor. So I need another method, and that's why I have completing the square. Okay, so the square root property there at the top says, if x squared is equal to n, then if I undo the square by taking the square root of both sides, remember, I'm the one taking the square root, so I automatically get the plus or the minus. So then it's the square root of n. Okay, so let's see what that means. This one says solve by using the square root property. All right, well, he looks a little dicey. When we were solving them by factoring, we had to set them equal to 0. But if we're going to use the square root property, we're not actually going to do that. Let's just look at this guy right here. X squared plus 14x plus 49. Does that guy factor? Let's try it. There's a plus and a plus, so it's going to be a plus and a plus. I need two numbers that multiply to 49 that add to 14. Seven and 7. Thanks, Abigail. Okay, well, I did it when we were factoring before. I didn't make you write that as a perfect square, but those guys are exactly the same, right? So really, that's x plus 7 squared equals 64. Okay, so there's my square root property. I have something that's squared, so I could take the square root. Okay, let's undo this square by taking the square root. So I get x plus 7 equals, I took the square root, so automatically I get a plus or a minus. And what's the square root of 64? 8. Okay, that's not too bad, right? Well, let's separate this apart. That means x plus 7 equals a positive 8, or x plus 7 equals a negative 8. And then I'm going to solve for x. So x equals, if I subtract 7, 1. If I subtract 7, negative 15. Notice I didn't get plus or minus 1. And I didn't get plus or minus 15. Also, remember when we were graphing them and solving them, we could have one solution, two solutions, or no real solutions. This guy is one that has 2. So what I'm doing is I'm trying to factor the left-hand side and force him to factor into a perfect square. so that then I can take the square root of both sides. And once I take the square root of both sides, I get a plus or a minus. I can separate it apart and solve it. Questions on that? Okay, let's try number 2 then. Let's see if we can factor x squared minus 10x plus 25. I have a minus and a plus, so this guy's a minus and a minus. I need two numbers that multiply to 25 that add to 10.
-5.
Yeah. Okay, I have two factors that are exactly the same. So I'm going to write it as x minus 5 squared equals 12. I want to undo the square, so I'm going to take the square root. Anytime you are the one taking the square root, I get a plus or a minus. Excuse me. Okay. Do I know the square root of 12? Over here I knew the square root of 64 was 8, but do I know the square root of 12? No, but could I simplify them? Factor tree them? Yeah, that's why we did all of that stuff there before. How does 12 simplify? Well, 4 and 3, 2 and 2. So this guy is x minus 5 equals plus or minus 2 root 3. And now I need the x by himself, so I'm going to add the 5 to the other side. So I get positive 5 plus or minus 2 root 3. How many solutions do I have there? 2, right? I've got 5 plus 2 root 3, and I've got 5 minus 2 root 3. Okay, let's do a little investigation with this guy. I want to leave our answer like that, but I just want you to see what's going on. 5 plus 2 square root of 3. Essentially, it's like 8.5, right? 8.46. And 5 minus 2 square root of 3 is about 1.5. That means when I graph this guy, I should see him cross about those places. Let's look at the graph. In order to put that guy in my calculator, though, I need him to be equal to 0. So 25 minus 12 is 13. Okay, so I'm going to put this guy in my calculator. X squared minus 10x plus 13. Whoops, sorry. He should cross the x-axis at about 1.5. Hey, look at that. And at about 8.5. Did it happen? It did. We are magical. Okay? So when we were graphing them on your 6-2 homework and we were using the left bound, right bound, and some of you are going to look at me like I'm speaking Chinese because you haven't done it yet. And we got a decimal answer. Really what he probably had was a radical with him. Does that make sense? Okay, questions on any of that so far? Okay. These two guys right here, x squared plus 14x plus 49 and x squared minus 10x plus 5, Factored nicely, right? Both of them factored into a perfect square. Is everything going to always factor like that? No, it's not. So if it's not, then we will force it to be. So if the quadratic equation is not a perfect square, you must complete the square. And here in the middle, it says to complete the square for any quadratic expression that's x squared plus bx, take half of b, so b divided by 2, square it, and then add it to the end. However, the coefficient of the quadratic term must be 1, meaning there's no number in front of the squared term. Okay? So like number 5 down here, we're going to have to do something. We're going to have to fix him for number 5 because his coefficient is 3 and it has to be 1. Okay, draw a little box around this guy because we're going to need him. This is what we're going to do. We're going to take b and divide it by 2 if b is even. If b is odd or a fraction, we're going to multiply by half. Those two are the same thing. Okay? Alright, so number 3 there says, find the value of c that makes x squared plus 16x plus c a perfect square. Then write the trinomial as a perfect square. Alright, so let's figure out what a, b, and c are. What's a? What's the coefficient of x squared? 1, right? What's b? 16, perfect. And c is what we're looking for. So, this guy, my box here says, take my b value, divide it by 2, and then square it. Okay, what's 16 divided by 2? What's 8 squared? 64. So in order for x squared plus 16x plus c to be a perfect square, that c value has to be 64. So in order for this guy to factor nicely into two terms that are exactly the same, or two factors that are exactly the same, that value would have to be 64. So this is really what we're looking for. Okay, so let's go solve some. Let's see how he actually works. Okay? So look at number 4. It says x squared plus 12, or plus 4x, excuse me, minus 12. X squared plus 4x minus 12. That's really what I meant to say. Alright. There's no two numbers that are exactly the same that multiply to 12 that add to 4. Would you agree with that? So let's force it to happen. So what I'm going to do is I'm going to move my 12 to the other side. So I have x squared plus 4x. Now I'm going to end up adding a box so that he does. I'm going to add something to him so that he does factor out nicely into a perfect square. So I'm going to put a box on each side, because if I'm going to add something to this left side of the equal sign to preserve equality, I have to add it to the right hand side. Okay, well, to figure out what goes in that box, I've got my little box up here, and it says take my b value, divide it by 2, and then square it. Okay. Okay, well, to figure out what goes in that box, I've got my little box up here, and it says take my b value, divide it by 2, and then square it. Okay. Okay, My b value is 4. I'm going to divide it by 2, and then I'm going to square it. 4 divided by 2 is 2. Square it is 4. So I'm going to put a 4 in each one of my boxes. Okay, remember we're forcing this guy to factor into 2 perfect squares. Okay, so we're forcing this guy to factor to have the exact 2 same factors. What would those factors be? Multiplies to 4, adds to 4. 2. Perfect. And then I'm going to write him as a perfect square. And what's going on with the right-hand side? What's 12 plus 4? 16. Okay, how do I undo things that are squared? Take the square root. So x plus 2 equals, I took the square root, I get a plus or a minus. Do we know the square root of 16? Yes, take it, he's 4. If you can actually take the square root, then let's separate them into our 2 equations. So x plus 2 equals a positive 4, or x plus 2 equals a negative 4. And then I'm going to solve both. Careful, they're both plus. So a plus and a plus is a plus. I want them to factor to be exactly the same. Yeah, so we added, so we added 12 to the other side. So he became a positive 12 over there. And then I'm forcing these guys to be exactly the same. Good question, Jaden. They should always be the same exact sign so that I could write them as quantity squared. Yeah. You're welcome. Good question. Thanks for stopping me. Okay, so now I'm down here and I'm going to subtract 2. So 4 minus 2 is 2. And I'm going to subtract 2, so x equals negative 6. Okay, how could we check those? There's lots of ways. What's one way we could check them? Stick them back in, right? We could plug x squared. We could plug 2 in for all those, right? So I could say, okay, 2 squared plus 4 times 2 minus 12. Hey, look, we got 0. And I could do the same thing with negative 6. Negative 6 squared plus 4 times a negative 6 minus 12. Hey, look, I got 0 again. Okay, that's one way. So you can plug it back in. What else? Graph it. We could graph it, right? I could throw this guy into my calculator and say, okay, x squared plus 4x minus 12. Where should it cross the x-axis? At positive 2 and negative 6. Hey, look at that. And when I look at my table, I have a 0 at positive 2 and a 0 at negative 6. Sweet. Okay? We could also see if that guy factors. Okay, questions on that one? Okay, before I do the ones with the coefficients out front, like 5 and 7, let's try number 6. All right. Are there two numbers that are exactly the same that multiply to 3 that add to 2?
2 and 1.
Are they exactly the same? No, they don't, right? Okay, so we need to complete the square. Let's move the 3 over and add in our boxes. So x squared plus 2x plus a box is equal to negative 3 plus a box. Okay, what's my b value? I have to figure out what goes in the box. What's b?
2.
2, perfect. I'm going to take b and I'm going to divide it by 2 and then I'm going to square it. Well, my b is 2, so 2 divided by 2, 1, and then square it. One times 1 is 1. Okay, now I want to show you some patterns. We know that this guy's going to factor into the exact same thing. So couldn't I just go and skip that step right there? If you're comfortable doing it, you could skip that middle step right there, and we could just write this guy as a perfect square, because that's what we're forcing him to do. We're forcing him to have two factors that are exactly the same. Okay, so let's figure out how we could figure out this number really easily. Well, that number right there is that number before I square him. Okay, let's see if it works up here. That number right there is that number before I square him. So really, it's the square root of my box. Would you agree with that? Square root of my box, square root of my box. So what's the square root of 1? Or the number before you square him? 1. It's also x, and it'll be that first sign. So, if that part confuses you, keep that part in there. We're going to factor them to be exactly the same. But really what I'm saying is I'm just going to skip that part because I know I have forced him to factor as a perfect square. Okay? So I have x plus 1 squared equals what? Negative 2. Okay, how do I undo things that are squared? Take the square root. I'm the one taking the square root, so the very first thing I'm going to do is give that guy a plus or a minus. What else do you notice about him?
Take out an I.
He's got an I, right? We got a negative under the radical. Okay, so I'm going to take out an I. Do I know the square root of 2? No, that's not one that we know, right? So he can stay. I also can't break him down. He'd be 2 and 1. And now I'm going to just get that x all by himself. And I'm going to subtract 1. So x equals negative 1 plus or minus I root 2. And we can leave him right like that because we don't know the square root of 2. And we also have an I. So that guy has a complex root. How many roots are there? How many root zero solutions are there? How many solutions is that? 2, right? We have negative 1 plus I root 2 and negative 1 minus I root 2. Okay, if I were to graph this guy, what do you think he would look like? Well, his roots are non-real now. So if he has non-real roots, is he going to touch the x-axis? No, he's not. Crazy, right? So he actually has two solutions, but they're not real. They're actually complex solutions, and we actually found them because we're smarty party pantses like that. I don't know. I just get really excited. Okay? After Christmas, after break, next semester, we'll get to the point where I will give you any equation and we can find its solutions, whether they're real or imaginary, which is way cool. Because no matter what I give you, we can find all of its solutions. This guy had two solutions. We found them, but we didn't see it on a graph. Well, because we didn't see it on the graph and it didn't cross the x-axis, it means that they're imaginary. Okay? I don't know. I think that's pretty sweet. Okay, questions on anything that we've done so far? Do you remember completing the square in Algebra 1? Maybe a little?
Oh, with the boxes and stuff.
Yeah!
Now, like, I don't know why now.
Yeah, that's what we're doing. Okay. Those two are a little bit easier because the coefficients are 1, right? But if we look at number 3 or number 5 and number 7, those guys have coefficients of 3 and 7. I'm just looking at your worksheet here. Okay. All right, so it said the coefficient had to be 1. So if we go look at number 5, is there something I could do to make that a 1? His coefficient's 3 right now. Yeah, divided by 3, right? And if I divide him by 3, I have to divide everybody by 3. Okay, I could do that. So I get x squared minus 2/3 x minus 1/3 equals 0. All right, and now some of you are going to go, oh, gross, fractions, right? Well, guess what? You have a calculator, and it's here to make your life easier. All right, that guy's not a perfect square as he is right now. So let's move our 1/3 over and add in our boxes. So I have x squared minus 2/3 x plus a box. Now you're always going to add your box. Equals a positive 1/3 plus a box. All right. Now, up here, in this little boxy right here, I said if b is even, use that one. If b is a fraction or odd, use that one. Okay, so what's my b value? 2/3. Kind of gross, right? So let's use our calculator. If you need one, they're up front. I'm going to take 2/3, times it by 1/2, and then square it. Ooh, grody. Two-thirds times it by 1/2. All right, so that's 1/3. And then I'm going to square that. So 1/9. Stop me. You okay?
I did. I don't know what my reason is for it, but
May come look at it.
wouldn't you multiply a half times that?
Yeah.
So you would multiply it times
Careful, 3 times 2 is 6. Could be 3, 6. Yeah, that should be 5 and 3 and 2 things, right? Speaking of that, on your test, I saw this. No, that's not what it was. It was 2 plus 2/3. So, do you know how many people? That was a plus. That's a plus sign there. What do you need when you add fractions? Common denominator, right? The same denominator. Do those two have the same denominator? People, I seriously, they were telling me that that was like 1, 4 over 4, 4 over 3. Yowzer. Okay, that being said, use your calculator. Okay, so we know what's in our box. It's a 1/9. I'm forcing this guy to factor. He's forced to factor as a perfect square. So I'm going to put my x. A minus and a plus is a minus and a minus. So that guy's going to be a minus. And the number in my parenthesis is the guy before I square him. So he's going to be 1/3. And don't trust yourself to add those two together. If you tell me that's 2 12ths right now, I'm going to beat you. Because it's actually 4/9. Okay, now what? Square root it. Okay, I have something that's squared. I'm going to take the square root. So I have x minus 1/3. I took the square root, so I get a plus or a minus. Ooh, this one works out nicely. What's the square root of 4? 2. What's the square root of 9? 3. When you add these two guys together and you take the square root and you have a fraction, the denominator should work out nicely. So it should always take the square root. Okay? All right, now let's separate it. I have more room I need. X minus 1/3 equals, sorry, that's equals a positive 2/3. And x minus 1/3 equals a negative 2/3. All right, let's see if we can do it without our calculator. 2/3, and I'm going to add a third. 2/3 plus 1/3. 3/3 are 1, right? Perfect. Negative 2/3 plus 1/3. Negative 1/3. So the trick is to leave it as fractions. Don't go to decimals, because if we would have had 0.67 there, it would have gotten a little nasty. Okay, questions before we do the last one? Okay. Remember, the coefficient has to be 1. And right now I have 7x squared plus 6x plus 2 equals 0. How can I make him 1? Divide everybody by 7. Okay, so I have x squared plus 6/7 x plus 2/7 equals 0. So now I'm going to subtract the 2/7 and add in my boxes. Okay, my box, remember, is my b. Divide it by 2 or multiply it by 1/2. And then square him. Okay, let's use our calculator. 6/7 times 1/2 is 3/7. And then we're going to square it. 9/49 is what goes in my box. Okay. I'm forcing him to factor as a perfect square. So I got an x. He's a plus sign. Plus and a plus is a plus and a plus. Pre-squaring would be 3/7. So x plus 3/7 squared is equal to 9/49. That's still in my calculator. Plus a negative 2/7. Oh, hey, look at that. Negative 5/49. I would really recommend you just use your calculator for your fractions. That way you're not dealing with the fear of having a fraction. Okay, now what? How do I undo things that are squared? Take the square root. So x plus 3/7 is equal to, I took the square root, automatically I get a plus or a minus. Technically this guy right here is the square root of negative 5 over the square root of 49. Okay, so let's fix that. What happens with the negative? Imaginary, he's an I, so I got an I. Can I simplify the square root of 5? Nope, so he today's I root 5 all over square root of 49. 7. Now, we didn't actually know the square root of 5. See how this guy had a radical? This guy was an actual number. These two guys were an actual number. This guy had a radical left. Oh, I'm pointing to things you can't even see. I'm sorry. See how that guy was an actual number? This guy has a radical. That guy had a radical. That was an actual number. If it's an actual number, separate it apart and solve it. If it's not, you can leave it all together. And I'm just going to subtract 3/7. So x equals negative 3/7 plus or minus I root 5 all over 7. And you can leave it like that if you want, or you can put it under one denominator. I'm good with this. You could write it negative 3 plus or minus I root 5 all over 7. Either one of those is okay. You could also have plus or minus I root 5 over 7 minus 3/7 if you want. I don't care the order. Okay, questions on completing the square? Okay, let's go look at your worksheet. Alright, there is a lot on here, but becoming a pro at completing the square is very important. When we get to chapter 8, we're going to complete the square a ton. So this is a skill that's not going away, just like factoring. So, here's what I want you to do. Pick 2 of the 3 columns. Does that make sense? So pick 1 column you don't want to do, but do 2 of the 3 columns. So that means in each section, the top section you can skip 3, the middle section you can skip 3, the bottom section you can skip 4. Does that make sense? You don't have to do the word problems at the bottom. Okay? Alright, so in the first section, I'm just going to look at this first one here. These guys are all factoring nicely in the first section. Okay, let's do that first one. The box has already been done. That box part is already done. These guys are going to factor nicely. Okay, so give me 2 numbers that multiply to 16 that add up to 8. 4 and 4. You're probably going to need some extra paper with this homework too. Okay, I'm going to undo the square by taking the square root. So I get x plus 4 equals plus or minus the square root of 1 is 1. So x plus 4 equals a positive 1, or x plus 4 equals a negative 1. Okay. Now I'm going to subtract 4. So x equals a negative 3. Or x equals a negative 5. So that first section is already done for you. Okay? It's already written as a perfect square. You just have to factor it and simplify. The middle section, think about this as you are just finding the box and then writing him as a perfect square. Meaning, I'm just going to take my b value, divide it by 2. So 12 divided by 2, 6. Then I'm going to square it. 36. So you're telling me what the box is and how he would factor. Then down at the bottom, I can guarantee you don't have enough room. So, a few things. When you turn this in, I need to make sure you see your work. If you just turn in this with the answers on it, I'm going to give you a big old fatty 0. Okay? I also have another hint for some of you. I have photo math on my phone too. Do I think it's a good resource to use sometimes? Heck yeah, I do. But I also know that it gives you some crazy weird crap sometimes. And I can tell when you're just using photo math and not actually doing the work. Okay? The answers are also posted on Canvas. So if you give me just the answers, super. Good job copying it down. Do the work, okay? That doesn't do you any good when you go to take your test. Okay, so on the bottom, you're going to move the constant over, add the box, complete the square. Does that make sense? So it's like working you into baby steps. These ones are factoring, these ones you're figuring out with the box, these ones you're doing the whole shebang. You can skip 1 column. Okay? Pick 2 of the 3 columns to do. Any other questions?